Hey everyone! I am still fighting off that cold, so I'm going to hide my face. But in this video, I'm going to cover exponents. Okay, exponent laws. So since I'm still a bit under the weather, I'm not actually going to go through these laws here. But what I'm going to do is refer you to this video here that actually goes through all the exponent laws. Now, the laws that you see here on the screen are the same laws as grade 9. This is just a quick little review of it. So if you need review on any of those, go ahead and take a peek at that video. All right, let's go through and simplify these expressions. So our base is the same, which means we just have to add the exponent. So this would be 2 to the exponent of 7. For b, base is the same, but this time we are going to subtract the exponents. So that's going to be 3 to the exponent of 3, which reduces to 27 if we were to simplify it. Yeah, it does want us to simplify, so sorry, that means we also have to simplify this one, which is 128. Okay, for this one here, we have an exponent that is outside the bracket, so we are going to distribute it in and multiply it to everything inside the bracket. That leaves us with 2 to the power of 3, a to the power of these exponents here, which is we're going to actually multiply because we're distributing. So that becomes 6 over b to the power of 6. 2 to the power of 3, this right here, becomes 8. So this is 8. A to the power of 6 and b to the power of 6. Okay, another one of these invisible ones. So technically this is 3 to the power of 1. And now we can multiply these. So we're going to add the exponents when the bases are the same. That's going to leave us with 3 to the power of 6. Okay, I will leave these with you. So pause it here, try these out, and then I'll show you the answers. All right, so our answer for E is going to be 7 to the power of 3. And our answer for F is going to be 27a to the power of 6. Okay, so these are the examples that I would say are probably more closer to grade 10 stuff, with example 3 being really close to grade 10 stuff. So what we want to do with this one is we just want to go through and distribute our coefficient. Now, since we only have a coefficient and a coefficient, aka those big numbers, all we're going to do for this one is multiply those. So that's going to leave us with 15. And these values here are going to stay the same. So 15a squared times b. All right, if we're looking at this one, we have this bracket here being multiplied here. So the only things that we can really multiply are the 4s. So 4 times 4 is going to be 16. Our a is going to hang out on its own, and our b squared is going to hang out on its own, coming together to become this. All right, let's look at this one. So again, I'm going to draw those arrows to help show where I'm multiplying. So those numbers can get multiplied. Now in this case, unlike that other example, we can actually multiply a times a, and we can also multiply b times b. So I had a student before, and she would call this the rainbow. She would say we're rainbowing everything in because the arrows kind of look like a rainbow. So let's go ahead and multiply it. 7 times negative 3. So remember, that's going to be a negative times a positive, which will get us a negative number. So this will be negative 21. And then we have a squared times a. That's going to get us to a to the power of 3. And then b to the power of 5 and b to the power of 6. We're going to add those exponents. That will get us to b to the power 11. And that's our answer. All right, D is division. So we've got that line, that fraction bar, which is just a fancy way of saying dividing. So we're going to go ahead and look at our numbers. 36 divided by 6 will just be 6. The A here has nothing at the bottom that we can divide it by, so it's just going to stay next to that 6. And our B, we've got technically B squared, which really means we have B and B on top with another B on the bottom. So what that means is each of those can get canceled, or we're going to subtract them. We're going to say we're going to say 2 take away 1. That leaves us with B, and there's our answer. last two here. So the first thing I want to do with this is I'll want to divide those. Now 10 cannot go into 15, but we can reduce both of them by dividing them by 5. So that leaves me with 2 over 3. And then our a's, we can subtract these exponents. So 8 take away 6 is 2. And then our b can hang out there, and our c can hang out there, and there's our answer. And finally for F is a little bit of a wonky one, so let's take our time with this one. So what I want to do first is rainbow in this exponent, and it does have to go to everything inside the brackets. So I'm actually just going to write this next to it to begin with. So the 3ab stays unchanged. Now we have 2 to the power of 2, a squared, b squared, over 2, a to the power of 3 and b to the power of 3. Now the tricky thing is because, that will be it. And then now what we can do is we can start to cancel out some variables. So what I noticed is I've got 2 a's here and 1 here. So technically speaking, if you can add those up, we actually have 3 a's on the top, or a to the power of 3 on the top, and an a to the power of 3 on the bottom. So what that means is we can actually cancel out those a's, because we've got 3 upstairs and 3 downstairs. Now it's the same thing with the b's. We've got 1 here and 2 here, that makes 3, and here's our 3 here. Now let's just look at our fractions, or our numbers that we have left. We have 3 times 2 to the power of 2. 2 to the power of 2, which I'm now going to change it to say 4 over 2. Well, 3 times 4 is 12 over 2. This just simplifies to 12 divided by 2, which is 6. Okay, so these are what I would say is grade 10 examples, maybe even kind of the moderate to harder level for grade 10. What I want you to do is give these all a try. So pause it here, and then I'll be back with those answers. Okay, so here are the answers for all of that. Now in the comments, let me know if you actually need me to go through any of them, and I will make a short little video for you explaining how I got these answers. Okay, so with these examples, what we want to do is we kind of want to do algebra, but in the sense of there being an exponent. So what we're saying here is we know that when we have an exponent outside the bracket, we have to multiply. So that's like saying 2 times m equals 10. And I'm getting those numbers from 2, m, and 10. Well, that one we know, we've seen that before. We know that m must equal 5. And as our examples get more complicated, one of the things I'll suggest is to make sure we go ahead and do that reverse operation, and that will prove our answer. I was just going through filming, and I just want to make sure I'm really clear about this. So what I'm doing here is I am ignoring the bases. And the reason for that is because we know that in order to get this answer, we had to do something with those two exponents. So in this case, we're using the law of distribution, or we're going to rainbow it in. So now I'm just going to ignore my bases and focus on those exponents. So this is the equation of what happens when just the exponents are being pulled out. 2 times m equals 10. And now I'm just going to solve for m, and that's going to get me our final answer. All right, let's look at this one. So for this one, we're saying 2m and 8 equals 14. Now let's look at our laws of exponents. We have the same base, which means we're adding these together in order to get the 14. So that's 2m plus 8 equals 14. So this is a great example of where we want to use those opposite operations. So I'm going to minus 8 from both sides. So that's going to get me 6. Divide both sides by 2 to get m alone. So m is equal to 3. And we can always go back and check it, right? So 2 times m, if m is 3, would be 6. and this would be 8. And so we know if we add those together, that would definitely give me 14. Okay, so for this one, we're saying, well, okay, a to the exponent of 7 over 3m equals a. Now remember, there's an invisible one here. So what I'm gonna do, like what I did with those last ones, is I'm gonna pull out those exponents. So 7 take away 3m equals 1. And remember, it's take away because we're dividing these exponents. So now I have to get m on its own. I'm gonna add a -7 to both sides. That leaves me with -3m is equal to -6. Divide both sides by -3. Can you tell I'm sick? I keep making all these silly mistakes. This was 6. I said 6 and wrote a 2. So m is equal to +2. All right, let's check that out. So if m is 2, that would make this 6. So 7 take away 6, yep, that equals 1. Okay, so just like last time, and I'm gonna be super clear about this one, I am going to pull out just my exponents and create an equation with them. So friendly reminder that that really has an exponent of 1. So now what I'm gonna do is I'm actually gonna add them up. So I'm gonna say m plus 2m take away 1 equals to 20. And again, just so we're clear, these two exponents have the same base, so we're gonna add them. This exponent has the same base, but it's underneath the division bar, so we're gonna take away, and the whole thing equals 20. So now I just go back and I use my normal algebra rules. These two are the same variable, so we can add those together. So 3m, they're also, sorry, I should add, these are also like terms. And if you're not sure how I got this, I'm gonna suggest you watch this video here on collecting like terms just to refresh yourself. So that's 3m minus 1 equals 20. So now I'm gonna go ahead and add a +1 to both sides to help get m alone. That leaves me to 3m equals 21. Divide both sides by 3, m is equal to 7. All right, last lesson for today. This is lesson 6, and this part here is going to be our negative exponents. So this we did not learn in grade 9 unless if your teacher was ahead. But basically the general rule is we, as math people, do not like negative exponents. So a negative exponent is really just saying we have a very small number. So the general rule for a negative exponent is if we have a to the power of -1, what we're gonna do is we're gonna raise it as a fraction. So that's gonna be a to the power of 1, okay? So another example, and just to kind of show you what I mean, is let's say we have let's use an actual number, 2 to the power of -3. So this means we don't want that negative exponent. We're gonna raise it over 1 and say that this is 2 to the power of 3 or 1/8. Now the way my actual math teacher when I was growing up described this, she said if you are in general living a negative life or have negative thoughts, you're most likely going to be dragged to the bottom. So that's your way of remembering this. Now mathematically, let me show you on a calculator what this actually means. Okay, so let's say I have my exponent 2 to the exponent of -3. So what it is actually a very small number. So in this case, it's 0.125. So it's a decimal number. And if we remember, if I go 1/8, well, I'm going to get the same thing in fraction form. So all I'm doing with the negative exponent is I'm really just converting it to a fraction form. And when we can't evaluate the fraction or the exponent, it's just going to look like that. Okay, let's try some examples. Okay, so for our first one, we've got an exponent of -5. We do not like that negative exponent, so that is going to go right here. Okay, with this one here, this same idea, we're going to put the whole base underneath. That -12 is getting a hug, and now the exponent is positive. In this one, we're gonna go the other way. So if it's a negative exponent on the bottom, we can do the opposite and bring it up. So that creates it to become a positive exponent of 7 to the power of 2. Now here's a wonky one. We still don't want negative exponents. So what we're gonna do with this is we're actually gonna take the reciprocal, which means we're gonna flip. So that's gonna leave me with 2 to the exponent of negative 5 over 3 to the exponent of negative 5, sorry. And now we're gonna flip it. This portion here, sorry, I'm working ahead of myself, was just to show you the distribution where both of them get that negative 5. And now we can flip it. So that's gonna be 3 to the power of 5 over 2 to the power of 5. All right, I'm not gonna go over the rational exponents because we just did it in the previous section, so let's move on. All right, let's go ahead and evaluate this. So we know we do not want those negative exponents. So that leaves us with something like this. Now it says we need to simplify. So really what we're saying is we're saying this bottom portion here is negative 4 times negative 4. So really we're taking a screenshot of it, or we're saying it's 4 squared. That's gonna leave me with 1 over 16. All right, so here's our next one. So this is similar to that previous example where we can distribute the negative 3 to both. That's gonna be 3 to the power of negative 3, 2 to the power of negative 3. Now we know we do not want those negative exponents. So that means we need to flip it, 2 to the power of 3, 3 to the power of 3. We then can go ahead and evaluate those. So that's gonna be 8 over 27. Okay, here is one with variables. So we're still gonna do the same thing. We're going to distribute everything. So that leaves me with a to the power of negative 2, b to the power of negative 1, and c to the power of negative 3. Now again, we only want positive exponents, so we can take the reciprocal of each by flipping it. And that's gonna get me the following. Okay, with D, let's go ahead and distribute that. That gives me 3 to the power of negative 2, a to the power of 6, negative 6. Again, we don't want any reciprocals, or we don't want any negative fractions, so that's 3 to the power of negative 2, 3 to the power of 2, a to the power of 6. And then this we can actually go ahead and evaluate. That gets me 1 over 9 and a to the power of 6. Okay, let's try this one. So the first thing I'm gonna wanna do is get my positive exponent, and that's gonna happen just by flipping this. So this is gonna become 5 over 3 to the power of 1. Now I can go ahead and distribute my 2. So that becomes 5 to the power of 2 times 3 to the power of 2. Now I can go ahead and evaluate this. This would be 25 times 9. And that's going to give me 225. All right, last one of these. This is kind of a fun one, if you will. So the first thing we know is anything to the power of 0 is going to become 1. That leaves me with 5 over 2 to the negative 1. I can go ahead and bring that up. So that's going to become 5 times 2 over 1, or 5 times 2, which is 10. All right, for these ones here, we're gonna do the same thing. What I'm gonna do is pause the screen here for you, and then give this a shot on your own, and then I will be back with those answers. Okay, so I did flash the answers for A, B, and C. What I did is I stopped at D because I thought we probably need an explanation on this in case we're a little off with fractions. So what we want to do first is distribute this, which means we need to multiply. But the tricky thing with this is it's a fraction. So we want to multiply a fraction by a whole number. So I'm going to ignore the base of A, and then I'm going to go 5 times negative 3 over 5. Well, in this case, it works out really nice. What happens is the 5s are going to cancel out. So this leaves me with a to the power of -3. Now again, we don't like those negative exponents, so that's going to be a to the power of 3. Okay, same idea. I'm just going to go over e as well. So again, we want to multiply this by this. So if I were to write that out, I'm going to ignore the base and go 4 times 3 over 2. And the way I did this is I'm going the 4 to turn it into a fraction, we're going to put a 1 underneath it, and then we're going to go top times top, bottom times bottom, which is where I got this. Then we can reduce that, so 12 divided by 2 is 6. So that takes care of the top. We have to do the same thing with the bottom. So the bottom is 2 over 1 times 3 over 2. Well, those can get canceled out. Now let's add those exponents to the bases here. So the top part, a, will be to the -6. And the reason it's negative is I didn't actually write it here, but there is a negative here. And then the bottom part would be ab to the exponent of 3. Now, with something like this, we can distribute this fraction, this exponent here. So that's a to the -6 over a3 and b3. This would be -6 take away 3. That's actually going to get me with a to the -9, and the b3 is going to stay. Now, since we don't want negative exponents, we're going to raise it all to a 1, and that negative goes away. So our answer becomes a to the power of 9, b to the power of 3. And just to clarify, I'm getting this 9 by going -6, take away 3. That really equals -9. So truthfully, it would have been a to the -9 up here, but we don't want negative exponents, so I brought it all down over 1, and now everything is positive. Okay, here's the last one, letter F. So this one can definitely be tricky because we're dealing with fractions. So two things we need to remember is how we add fractions and how we multiply fractions. So with adding fractions, we are going to need our common denominator. And with multiplying fractions, we're just going to go top times top, bottom times bottom. All right, so for the first thing with this, let's just focus on this portion of the simplification. So we can see we have an exponent and it's outside the bracket. So that means that exponent needs to be applied to everything inside the bracket. So our 5 becomes simply -3 over 2, and that's the exponent. And that's because, again, there's that invisible 1. So we're just multiplying 1 times -3 over 2. And then the next one is the 2 times -3 over 2. So I'm going to do that on the side. And let's ignore the fact that they are exponents, and let's just think about them as numbers. So 2 times -3 over 2. Well, what I'm doing is I'm multiplying a whole number by a fraction. In case we forgot, what we'll do is we're going to, again, pop an invisible 1 because every whole number actually has a 1 underneath it when we want to turn it into a fraction. And then we can multiply these two by these two. Well, that reduces to -6 over 2, which then reduces to -3. On the same note, we also can just cancel out our 2's, and we would be left with -3. So this portion now becomes a to the power of -3. All right, so that takes care of that. Now this whole thing, all of this is being multiplied by this. So now what I want to say is, well, okay, if we're multiplying this by a1/2, we can only multiply the ones that have like terms. So in this case, the a and the 8. So again, I'm going to pull that out here on the side here. So what we're saying is -3, and it is an exponent with the same base, so we're going to add it to this exponent. So that means we're going to be adding these fractions here. So this is where I'm going to need that common denominator. So again, we know there's an invisible 1 hanging out here. And so if I multiplied this fraction, both top and bottom by 2, I'm going to get a common denominator. This gives me negative 6 over 2 plus 1/2. Now I can add the top numbers. So negative 6 plus 1 would give me negative 5 over 2. So that means when I multiply those bases, I need to add the exponent, and the exponent is now negative 5 over 2. So let's rewrite all of this. So I'm just copying what I have above. And then this exponent here is negative 5 over 2. So that is almost our answer. The key thing is we know we need our positive exponents. So that means I need to bring everything down. So this is going to be 1 over 5a to the power of 3 over 2 and a to the power of 5 over 2. And that is our final answer. Okay, that is it for this video. I hope that was helpful. Please let me know in the comments what I can do better to help your learning. And just as a reminder, I do hold those 101 sessions. Information for that is in the description. Until then, everybody, I'll see you all in the next one.